The polynomial f of x is defined by this. Use the remainder theorem to find the remainder when f of x is divided by this. The polynomial g of x is defined by this. Given that 2x plus 1 is a factor of g of x, show that g of x equals to this. Part 2, given g of x can be written as this, where a is an integer, express g of x as a product of three linear factors, hence or otherwise show that g of x over this is equal to this, where p and q are integers. So that's the question then. I've got it summarized here. So let's have a go at part A. So remainder when f of x is divided by 2x plus 1. So let's put in minus a half, isn't it? That's when this is 0. And find out f of minus a half, and that would be the 0. So f of minus a half is equal to 2x cubed plus x squared minus 8x minus 7. The x value inputted is minus a half. Put it in here, here, and here. And then we can work out the remainder. Minus half cubed, one of the twos will cancel. We'll just get 2 squared, which is 4, so it'll be minus 1/4. This will be plus a quarter, won't it? Half squared with a minus. And then minus times minus is a plus. 8 over 2 is 4. Take away 7. These cancel. 4 take 7 is minus 3, so that's the remainder. So this was part 1. Now part 2. G of f of x. G of x is equal to this, and this is a factor. So g of minus a half, because 2x plus 1 is a factor, equals 0, is equal to, well, it was f of x, which is 2 times, well, the f is equal to f of minus a half, so let's put it in. Plus d, which equals f of minus half is minus 3, we just worked that out above, plus d. So that tells us that d is equal to 3. Because this is equal to 0, isn't it? Because 2x plus 1 is a factor. So we've got that then. So g of x then will equal 2x cubed plus x squared minus 8x minus 7, and then d was equal to 3, so it's plus 3, which equals 2x cubed then, plus x squared, minus 8x, minus 7 plus 3 is minus 4. That's what we wanted to show. Let's just see that above. Yeah, that's fine. Here it is here. G of x equals this then. A is an integer. Express g of x as a product of linear factors. So we're given this, and we know g of x is this. So we can make this equal to that then, and see what comes out. So 2x plus 1 times, was it x plus a? Or is x squared? X squared plus a is equal to g of x, 2x cubed plus x squared minus 8x minus 4. So that was a, okay, that was B1 here, and this will be part 2 onto it. Let's just go back and check B part 2. G of x equal to this. Express g of x as a product of linear factors. Okay, so we need to get a here. Let's equate constants, because here we'll just get the a itself is equal to, and the constants on this side, when x is 0 basically, is equal to minus 4. So we've got x squared minus 4 here, haven't we? So g of x then will equal to 2x plus 1, and we can write x squared minus 4 as x minus 2 and x plus 2, complete difference between two squares, isn't it? And there's the product of three linear factors. So g of x is equal to that. Hence show that g of x over that is equal to this. Okay, hence show that g of x over this okay, is equal to this. Let's have a look at it then. There's an x common all the way through here. Let me just check that I've written that down correctly with the paper. Yeah, it's fine. So, g of x over this then. So this was, what part was it? The p part 3. Here, we've got 2x plus 1, x minus 2, x plus 2, over. Now underneath, let's see what we've got in the question. 2 minus 3 minus 2. 2x cubed minus 3x squared plus 2x. Okay, minus 2x, wasn't it? See it? Minus 3 minus 2. So that's a minus, just put that in. So we've written it down correctly, so let's have a look at this. There's an x common here. X minus 2x plus 2. And take the x out as common, and that will leave 2x squared minus 3x minus 2. So that's equal to then 2x plus 1, x minus 2, x plus 2, over. Now here we've got an x, but there's a 2x, if we factorise in an x. We've got a 2 here, so let's put the 2 there to give 4 and 1, and the difference will be 3, provided that's a minus and this is a plus. 2x squared minus 4 plus 1 is minus 3x, plus times minus is minus, and 2 ones are 2, so this is all fine. So the 2x plus 1 cancels with this one, and the x minus 2 cancels, and we just get left with x plus 2 over x, which is equal to 1 plus 2 over x. So let's go back to our original. I split the fraction up here. X over x is 1, and then plus 2 over x. Just split the fraction up. These were cancelled because they were common. This one and this one here. So we just left x plus 2 over x. So let's just go back up, check the question. So that was nice and straightforward. P plus q over x. So we can write down p and q, where p and q are integers. So p is 1. Q is equal to 2. And they're integers.